All right, this is a continuation of factoring polynomials. So earlier in our chapters, we factored using the difference of two squares. So I'm just going to review that with you. So the difference of two squares was a squared minus b squared, so two perfect squares with subtraction. You factor that as a plus b, quantity a minus b. Now we're introducing two more factoring methods called the sum and the difference of two cubes. So when you have the sum of two cubes, you're going to use this rule. And when you have the difference of two cubes, you're going to use that rule. So let's go ahead and practice it. So example 1, factor the expression x cubed plus 27. So first thing I'm going to do is I'm going to write that 27 as a perfect cubed. So it's x to the third plus, and now 27 is the same thing as 3 cubed. Now we're going to use the rule that is the sum of two cubes. So we're going to use this top equation right here, and we're going to enter it into the right side of the equation. So I'm going to write the rule right above it. So a cubed plus b cubed in factored form will be a plus b in the first parentheses, and then a squared, and I'll be very careful with this sign right here. It's going to be minus a times b plus b squared. So let's go ahead and substitute into the right side of that equation. So a plus b will be x plus 3. In the second parentheses will be x squared minus x times 3 plus 3 squared. And then you always need to simplify that second parentheses. So x plus 3 is the first parentheses, and then x squared. Negative x times 3 is negative 3x, and then 3 times 3 is 9. Example 2. Now we have a difference of two perfect cubes. So I'm going to write the rule, a cubed minus b cubed. In factored form is going to be a minus b, quantity a squared. Now notice this will be a plus a times b plus b squared. So we're going to write the perfect squares. So 125 is the same thing as 5 times 5 times 5, and then x cubed. So that will be our a, and then minus 8 is the same thing as 2 times 2 times 2, or 2 cubed, and this will be our b. So we're going to substitute it into the right side of the equation. So up here in the green. So 5x minus 2, and then the second parentheses. Be very careful, it's going to be a squared, or 5x all squared, plus 5x times 2 plus 2 squared. So just like the last example, we need to simplify that second parentheses. So 5x all squared is 5x times 5x, or 25x squared. And then we have 5x times 2, 10x, and then 2 times 2, which is 4. All right, example 3. What's different about this problem is it has a GCF in its expression. So the GCF of those two terms is 4x. We have to factor that out first. So we factor out our GCF, and we're left with x cubed plus 27. Now we're going to go ahead and factor the green piece using the difference or the sum of two cubes. So the 4x stays outside, and then we have x cubed. I'm going to rewrite that 27 as 3 cubed. So now we factor using our sum of two cubes. So x plus 3 will be the first parentheses, and the second parentheses will be x squared minus x times 3 plus 3 squared. Now we simplify that second parentheses. So negative x times 3, negative 3x. 3 times 3 is 9. Here's our last example. We have 64. I'm going to write that first as a perfect cube, so that's 4 times 4 times 4. And we have x cubed, so our a term will be 4x. Our 1 is 1 times 1 times 1, or 1 cubed, so this will be our b. And then we factor it as a minus b. Then we have our second parentheses, 4x all squared plus 4x times 1 plus 1 squared. And then we simplify that second parentheses. So 4x times 4x is 16x squared. 4x times 1, 4x. 1 times 1 is 1.